Tired of studying physics longer, but want to learn physics in a few minutes? This video is for you. Hey guys, welcome to our quick physics tutorial wherein we will answer physics problems step by step. In this tutorial, develop your analytical skills in a matter of 10 minutes. Improve your comprehension in physics concepts. Study at your own pace and study at your best convenient time. Please don't forget to hit the subscribe button below and click the bell for more updates. See you in a bit. Ready? Let's begin. This problem is about finding the uniform acceleration of an object. A train moving 16 meters per second east of uniform acceleration is found 20 meters away from its designated station. At 2 seconds, solve for the acceleration of the train, and was it able to stop at the designated station? Step 1. Identify the given data. In here, the initial velocity of the train is positive 16 meters per second and is 20 meters away from the designated station. At 2 seconds, solve for its acceleration. And letter B, we want to solve for its final speed to know if it stopped at the designated station or not. But first, we must know the standard set of 4 equations needed to solve problems involving constant acceleration. We start with the basic expression of average acceleration, or acceleration, which is the change in velocity over change in time, or final velocity minus initial velocity over final time minus initial time. We let initial time to be 0 and final time to be expressed as t, so that our acceleration would then be equal to v final minus v initial over time. Rearranging it, we get v final equal to v initial plus acceleration times t. This is now our first standard equation. Next, we recall our expression for average velocity. This is displacement, or change in position over change in time, or equal to x final minus x initial over time t. Rearranging it, we now get the second standard equation to be x final equal to x initial plus average velocity times t. Since the average velocity can be expressed as initial velocity plus final velocity over 2, we could replace the average velocity and write the second equation as x final equal to x initial plus v initial plus v final over 2 times t. Then, we replace v final using the first equation in order to get this. Simplifying the equation, we have xf equal to xi plus 2vi over 2 plus at over 2 times t. Canceling 2 on our second term, we now have our third standard equation as xf equal to xi plus initial velocity times t plus 1/2 at squared. Going back to the second equation, wherein we replace the average velocity with v initial plus v final over 2, we replace t using the first equation with t equal to v final minus v initial over a. Incorporating them, we get this equation. For this one, we recall this algebraic expression. A plus b times a minus b, we get a squared minus b squared. Relating this to our equation, we get vf plus vi times Vf minus Vi equal to Vf squared minus Vi squared. We now have Xf minus Xi equal to Vf squared minus Vi squared over 2a. Cross-multiplying them, we get this. So the fourth standard equation would be Vf squared equal to Vi squared plus 2a times Xf minus Xi. Listing them all, we now have our four standard equations under constant acceleration. Using these equations, we can now solve problems involving constant acceleration. Going back to the main problem of train with initial speed of 16 meters per second and 20 meters away from the designated station. The problem asks for the acceleration of the train at 2 seconds. So we write the four standard equations. Step 2 is to choose an equation involving only one unknown variable. Looking at equation 1, we know that in this equation we have two unknown variables, the final velocity and the acceleration. So we could not use equation 1. Now we proceed to equation 2. Looking at equation 2, we know that we could not use it because there is no acceleration in the equation. Remember that the problem is asking for the train's acceleration. Also, we cannot use equation 4 since it has two unknown variables, v final and acceleration. Now we proceed to equation 3. In this equation, the only unknown variable here is the acceleration. The rest of the variables are given in the problem, like the xf, xi, vi, and t. So we can use equation 3 to solve for letter A. Step 3. Solve for the acceleration using the third standard equation. Plugging the value of each variable, we get Vi 16 meters per second times 2 seconds time plus 1 half A times 2 seconds squared equal to Xf 20 meters where Xi is 0. Transferring 16 times 2 equal to 32 to the right, we get 1 half A times 4 equal to 20 minus 32. Simplifying the equation, we write 2A equal to negative 12. Dividing 12 by 2, we get acceleration A equal to negative 6 meters per square second. So, the acceleration of the train at 2 seconds time is negative 6 meters per square second. Next, to solve for letter B, the final speed of the train, we write again the four standard equations. Step 4 is to choose an equation involving only one unknown variable to solve for the final speed of the train at 2 seconds. Looking at equation 1, the only unknown variable is the final velocity, so equation 1 can be used to solve for letter B. However, we cannot use equation 2 since it has no final velocity Vf to answer letter B. Same thing with equation 3. It has no final velocity Vf, so we cannot use it. On the other hand, we can use equation 4 to solve for letter B, since it has only one unknown variable, the final speed Vf. Hence, we can use equations 1 and 4 to solve for letter B. Either of the two, they must give the same answer. Using the acceleration obtained from letter A, we can now solve for the final speed of the train at 2 seconds. Equation 1 is straightforward. Plugging the given values in equation 1, Vf is equal to 16 meters per second plus negative 6 meters per square second times 2 seconds. Simplifying the equation, we get Vf equal to positive 4 meters per second. So the final speed of the train at 2 seconds is equal to 4 meters per second. Using the acceleration obtained from letter A, we will solve again the final speed of the train at 2 seconds using equation 4. Plugging the given values in equation 4, Vf squared is equal to 16 meters per second squared plus 2 times negative 6 meters per square second times 20 meters, where xi is 0. Simplifying the equation, we get Vf squared equal to 16. Getting its square root, the final speed is equal to 4 meters per second. So either we use equation 1 or equation 4, the final speed of the train at 2 seconds is 4 meters per second. Since the final speed is 4 meters per second greater than 0, this means that the train was not able to stop at the designated station. The train just passed the station at a speed of 4 meters per second. Let us have a little exercise. A train moving 16 meters per second east of uniform acceleration is found 20 meters away from its designated station. At 3 seconds, solve for the acceleration of the train. And was it able to stop at the designated station? Just follow the previous steps and you will get the same correct answer. And we're done! Thank you for watching! Please don't forget to hit the subscribe button below and click the bell for more quick physics tutorials. Like and follow us on our Facebook page. See ya!